I just had a customer send me a job file he's having some problems with. He's got this 3D sign, and when he machines it, he's not getting the full depth of cut across the 3D object. So I asked him if he had embedded it into the material, and he had not yet. And that's the issue. So if we look at this, there's a couple things that we can do. Let me jump over to the tool pathing side so you can just kind of see what the whole thing is going to look like. So he's engraving just with a V-bit and then doing a ball nose here to do the 3D and then the cutout. He's got tabs. So everything looks good, except he says he's getting flat spots on the 3D engraving. So what that means is the 3D object is up too high in the design. And there's a way to quickly check this. When I first got the job in, I went to material, I highlighted the 3D object, and it's not positioned below the top of the material. So what I would do is position it below. I'd also set a zero plane so this outside rim is cleaned up a bit. Without that, depending on how you're optimizing the cutout, you can have some jaggies around this edge. So here's what I would do. I'm going to jump back over to the design side, and I'm going to go to the modeling. Okay, so we come over here. We see that his 3D shape is a 1/2 inch. That's fine. It's 3/4 inch material, I think. I'm going to look at that, but that's what we want to look at, what we're working with. So if we go to our material setup, the thickness of the material is only 3/4, is only 1/2 inch as well. So we're going to plunge either right through it or have zero thickness material below it, because the thickness is 0.5 and the depth of the 3D object is 0.5002. So we're going to go through it. That doesn't make much sense. So I'm assuming he's stuck with the material that he's working with. So let's make this a 0.375. And then tab. And then close. And then when we come over to the tool pathing, we can look at this. And right now the model is at the top of the material. That's fine, but I'm going to put it down 0.0625. So I'm going to add a 1/16 of an inch, so it's barely coming down. So we have a 1/2 inch material. We're coming down a 1/16, 3/8 thickness for my 3D object. So that only leaves me with a 1/16 underneath it. That's fine, depending on the material. And I'm not sure what material he's using. So we can make that a 32nd. We can do whatever. But what we want to do is make sure that this area is dropped just a tad. Because if you haven't set up the upper beam to be perfectly parallel to the material in this area, then you could have it flat spotting up at the top. If your upper beam is not perfectly parallel, you could have a problem. So let's take, this gives us a 1/16 of an inch of a wiggle that you won't see because we're just dropping this down 6 inches. I have 2 other videos pretty far back from when I was carving some Romark. So it had a thin color up at the top and then a white middle layer, and you wanted to see both. But the size of the font that we were working with was so small and such a thin, single line cut that if I hadn't surfaced my spoilboard before attaching the Romark, as it was typing out, an example would be a sentence, it would get deeper because we're only talking thousandths of an inch sometimes with this engraving. Same thing with this 3D engraving. If the top of that horse right here, say that's the high point, is at the top of the material, but I don't have my material properly placed exactly perpendicular with the spindle, it's going to be deeper in some areas and shallower in some areas. So the very simple way to do that is to embed this down a little bit. You could also surface this material first if you want to, and then you could have this still up at the surface. But we certainly can't do a 3D object that's minimally but thicker than the material. That won't work. So it's proper. Touch off of the tool is required. So you can touch off using our touch plate. If you're not using the touch plate, or the touch plate is defective and you're waiting for a warranty piece or whatever, we go old school. Use a piece of paper and you lower your bit until you snag the paper. Um, and then we're off the thickness of the paper. So you can either change the depth of cut, or you can move it off of the material, tell it to go to Z0, and then using the center of the jog wheel, convert it to 0.1 millimeters and go down another 0.1 millimeter. But in this case, he was having flat spots. So let's either drop this down or adjust the depth of the bit, because it's not perfectly perpendicular, and we've got other issues with the way he designed it. So all that can be fixed. It's all a software thing. It's not a machine thing. It's based on understanding how things process through the workflow of a job, getting it to the machine. So that's what I would do. Tell it okay, recalculate everything, and he should be good to go. And again, if we want to make that a 30-second, that's fine. Let's just make sure that it's cutting everything away. Material values have changed. That's correct. So I'll recalculate all tool paths, and it's working it out. And there we are. So I'm going to process this real quick to get it back to the customer so you can see exactly what we're talking about, and we should be good to go. Thank you for watching. I'm Eric Schiller with Yeti Tools Southeast, YetiSmartBench.com. My phone number is 205-871-6618.